Good evening, guys. Welcome to CodeLab. In today's lecture, we'll be talking about integer. So, in our last lecture, we treated number systems, and I hope you guys understand what number system is by now. And in today's lecture, we'll be talking about integer. And if you remember clearly, or if you should carefully watch or understand the last lecture, I brought up a particular topic which is data type and variables. So in today's lecture we'll be talking about those data type and variables. So we are starting from the start of data type and variable here. So in today's lecture we'll be talking about integer, and we will try and understand what's or more about integer. So now let's move to the next slides and check what is there. So I want to explain what integer is for you. I want to explain it very good what integer is for you. So let's say this is Mr. Sorry. So let's say this is Mr. Ortega. So this is Mr. Ortega here. This is Mr. Ortega, and these are the possession of Mr. Ortega. These are the properties of Mr. Ortega. So Mr. Ortega have an house here. Mr. Ortega has a bed. Mr. Ortega has chair and kitchen sets or kitchen's items. So Mr. Ortega has a lot of possessions here, and all these things we have here, they all belongs to Mr. Ortega. Everything you see here, they all belongs to Mr. Ortega, because it is right here that all those things here belongs to Mr. Ortega. So let's try and clear the screen, and good. So now this is Mr. Ortega, and these are the things or possession or these are the properties of Mr. Ortega. Wherever we see this house, so we can actually identify the house, or we can actually call the house Mr. Ortega's house. Or wherever we see the house, so wherever I see this house, sorry, it's too big. So wherever we see this house, so we understand that this is Mr. Ortega's house. Wherever we see this bed, we will know, or we will try and identify that this is Mr. Ortega's bed, because it belongs to Mr. Ortega. So I want to use that as an example of how your integers work with your C++ programming. So now let's move to the next one. If you should clear this, let's clear this thing here. And let's move to the next one. Next slide, So now we have Mr. C++ and we have Mr. C++ possession. So now this I'm trying to say is that Mr. C++ has possessions, has a lot of property, just the way Mr. Ortega has the property. Just the way Mr. Ortega have this particular property here. So Mr. C++ too has his own possession, so which is called data types. But if we should go to this next slide, we can also call it home living items. So let's just say home living items or home living items icon set. So let's call it home living items or home living. But here we call our own, we call C++ own, we call it Mr. C++ items data types. So in each data type there has their meaning and has their purpose. Just the way Mr. Ortega has house and has purpose. We know that if Mr. Ortega wants to sleep or wants to have a rest or wants to have a family, he has to get a house. And if Mr. Ortega wants to sleep, if Mr. Ortega wants to get or have a family and live in, he has to get the house. And if he wants to get or want to sleep, he has to get the bed. He has to sleep on the bed. If he wants to sit on the couch, he has to go to the couch and sit. If he wants to watch TV, he has to or sit on the couch and watch TV anyhow. But everything we have here has purpose. House has purpose, or has the purpose, has purpose or benefit to Mr. Ortega. And the bed has purpose, and the chair has purpose. They all have purpose to Mr. Ortega, because they are all belongings of Mr. Ortega. They are all properties or protection of Mr. Ortega. So everything we have on the screen here, or everything we have here, they are all the property of Mr. Ortega, just the way, just the way C++ has this particular property. So now let's try and understand C++ himself. So let's assume C++ is just like Mr. Ortega, who has properties, and every property has the purpose. Every property has a purpose. Every property has a purpose. Both this and all this, they have their own purpose. So Mr. Ortega has what we call integer. Integer has a purpose. Mr. Ortega has Mr. Ortega has float. So float also has a purpose, and double. They all serve a purpose for Mr. C++. So every possession of Mr. C++ has purpose for it, has a way of benefiting it. So C++ benefit from this place. C++ benefit from float. So C++ benefit from C++ benefit from float. C++ benefit from integer. It benefit from double, because they are all the possession of C++. They all belongs to C++. They are all the properties of C++. So I want you to understand that this C++ is just like Mr. Ortega, who owns property, and the properties are these. But in programming world, we call it data type. In programming world, we call it what? Data type. So everything we have here, we call all together, we call it data types. Instead of calling it possession or home living or property or whatever it is, we call it data types. Or you can call it identifier also. So they are identified by C++, though they are the identifier of C++. So whenever we see this, we say, oh, this is C++ identifier. So I mean, whenever we see integer, we will know that this is C++ identifier. Whenever we see float, we will know that this is C++ identifier. So these are the properties of C++. So I want you to understand that now. But in today's lecture, we'll be talking about integer. We'll be talking about this particular property or this particular possession, just like the way we have house here. So now let's assume we want to talk about house, Mr. Ortega house. But don't get confused. I am not talking about house. I'm talking about integer in C++. Slide, I mean. So let me just clear this thing away. Okay, good. So now in the next slide, we're talking about integers. So now integers stores decimal. I hope you know what decimal is. So integer stores decimal in memory. So integer is what we call data type. It can be called data type. Integer can be called data type, or it's called data type. Not even can be called data type. It is called a data type that stores. We have it here. Sorry. So we have, sorry about that. So we have integer here, and it stores. So one of the property or one of the possession of C++, we have integer, or one of the property of C++, we have integer. So this integer here, it stores decimal number. I guess you know what decimal number is, and when we talk about, in our last lecture we use decimal a lot, and I hope you guys understand what decimal is. So it stores decimal, and if you really don't understand what I mean, sorry. So decimal are just like this. Sorry about that. Decimal are like 1, 2, and 3, 4. So these are decimal number. So minus 100 is decimal. Minus 200 is decimal. Minus 5,000 is decimal. So all these things are numbers, they are stores, or let's say it stores. This one have power or direct association with decimal. So it only stores decimal in memory. I hope you get, or I hope you understand what I'm trying to say. So integer stores decimal numbers or decimal in memory. It stores only decimal in memory. So I want you guys to understand what integer is used for. Just like our house, like in the Mr. Ortega's property, house is used to relax, to make up or to build a family, or to have a place to rest after coming from the work for a whole day. Or let's just use bed, a very good example for that. I can't really talk about house here. So let's say bed. So bed is used to sleep or to rest or to take a nap or any stuff like that. So now we're just talking about integer as this particular aspect that has purpose. So the purpose of integer is to what? To store decimal number, which start from minus 1000, or it start from negative, and it start from negative number, which is negative decimal number, and ends at the positive decimal number. So I hope you guys understand what I'm trying to say. And our integer stores 4 bytes in memories or more. We talked about memory, and we talked about it stores 4 bytes in memories and or more. And in our last lecture we talked about bytes. We talked about number systems, and we actually explained, or we talked more about memory, the way our data has been stored in the memory. So now every integer types, or anything you use, every variable you use with integer, or every variable you use with integer stores 4 bytes in memory or more. It can be more than 4, and it can be more, but specifically it stores, or let's say specifically it stores 4 bytes in memory. And let's go to the next slide to try and understand what that means. So you understand that integer is a data type or a property of C++ that stores decimal number, and it contains 4 bytes in memory. So I want you to understand these two things. They are very important. So now let's go to the next slide. Here we have this list of memory. Let me clear this stuff away. So in memory, this is our memory here. Sorry, this here is our memory. Sorry, my drawing is very bad, very bad. I know my drawing is very bad, but I'm very sorry about that. Just try and adapt, or pardon my, oh god, still drawing error. Anyway, this particular good. So this is the memory of integer. It stores what? 4 bytes. If we should count it one by one, we will get to, we understand that a single cell is called bit. A single cell is called bit. So 4 bits, or is it 4 bits? Sorry, 8 bits makes 1 byte. So 1, 2, okay. Let's say 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits. 8 bits, yeah. That's very bad. That's not good. So 8 bits is actually 1 byte. Sorry, just 1 byte. So 8 bits is actually just 1 byte in memory. So we have this 4. This here, from here to here, is what we call is 8 bits, which is 1 byte. So we have actually, integer actually stores or contains just 4 bytes in memory. 4 bytes. It doesn't take more than 4. Specifically, that's 4 bytes in memory. So the memory we have here is 4 bytes. If you should count it from this particular angle to this last angle here, they are all 4 bytes. It's just 4 bytes. So 8 bits 1 byte, and integer stores from the first bit here to the last bit here. So which is actually altogether it's called, altogether they are 4 bits. 4 bytes. Altogether there are 4 bytes, which is here. It's already here. So altogether there are 4 bytes. So integer store 4 bytes in memory. And how can we manipulate, or how can we have access to our value? And the only way we can have access to our value is when we declared our variable. And let's say there's a variable called grade here. So grade is assigned, or let's just say integer. We create the variable of integer, also we create the data type of integer, and we give the value, or we give variable to it. We give grade. We assign grade to the memory or to the address of this particular place. The only way we can have access to our address, the only way we can have access to this particular memory here, or our memory here, is when we declare a variable. A variable is just like we are actually giving it a mini, so we are giving it an address, because there are a lot of memories in computer. There are a lot of integer memory. If you should go to the next slide, we see very much of it. So let's just try and go to news. Even more than you see there. Even more than. So yeah. Let's see. So this is it here. So now this is the memories of integer. There are a lot of memory. So we have a lot of it here. So we have a lot of memory, or we have a lot of numbers, which is binary numbers in the memory. So how can we have access to this memory? How can we have access and say, okay, now if I should declare my variable here, or if I should declare my integer, or use this particular position, how can I have access? Sorry, I'm very bad, Troy. I'm not even good at all. So if I want to have access to this particular memory here. I want to have access to this particular memory. The only way I can have access to the particular memory here is when we declare our variable. So variable helps us to give it address. To make sure this is an address. Because without the variable, we won't be able to have access to the address. Now, if we should just declare integer and we didn't give it variables, how can we have access, or how can we be specific that yes, this thing is declared here, this data type is declared here, or is declared? The only way we can actually give it mini, or make it have mini, is when we declare a variable. So in memory we have 4 bytes, and it's an integer, and we store the variable, or we give the variable address. We give the memory address grade. So this is the address of the integer we called. So it points to the address, to the specific place we declared or we use our data. Now let's go to the next class. Let's go to the next slide. Very sorry for that. So in the next class here, we have what called variable, and variable is variable a name of piece of memory that is used to store specific data. So it is the name of memory that stores the data we have. A piece of memory that is used to store a specific data. Now we declared, we said int. Okay, maybe I want to use the value. I want to use the number of 10. I want to use the number of 10. I want to store 10 in the memory. I want to store 10 in the memory. In the last lecture, we talked about how we can actually how we can use, or how we can convert our decimal to binary. So now I want to say I want to use this format, or I think we talk about our realistic number systems, or method of dealing with numbers and characters being converted to binary. But now let's try and understand more about this. So I use integer. I declared I want to use the value of 10, and to actually have access, or to be able to have access to this integer or use this integer, I have to declare a variable. So I said I want a number of 10, and I have to give it a name. So it's just a name. So what name could I give it? So it depends on what you want to use it for. Maybe you want to use it for something like, okay, let's say box. Let's say box. So let's say box. The box contain the value of what? 8. So now you giving it 8 is giving it data, giving it value. So now I said this one contains what? Contains 4 bytes. Not good. 4 bytes. In memory. So this particular one here is just a piece of name that is representing the value of this. This is where the value is being located himself. So this one here is just a piece of name that stores the value of 8 that you have here, that make you use this particular integer here. Assuming you give it text or character like T, Y, P, or you just type something else, not number, it's going to give you error, because what we have here is not the location. It does not support anyhow character. It only supports what? Numbers. I hope this thing is not too rough. I'm so sorry. I think it gets too rough. So it only supports numbers. So now I want you to understand that variable, and this is an example of variable that we do. This is a variable here. So in the next slide we have variable actually is a variable is a name of piece, is a piece of memory that is used to store specific data. So it's just a name, and that is used to store data we want to give it. So in the previous, or in the earlier explanation, I said I stored the value of 8 in the value in the box, which is I store the value of 8 in box, and the box is called variable because it accepts data that I actually stored there. It collects data. And in the next slide here, let's just go deeper more. So here we have the types of initializations. Initialization is how you give the value to the variable, how you assign value to the variable. Like how to assign a value to a variable. Sorry, I'm not really good in this, using this particular one. So let me go back to my normal part. I don't think I have complication with this. It's complicated a little bit, and sorry. So if we should move closer, I want you guys to see variable. That's why I actually go to this particular place. So now we have what we call types of initialization, the way you assign your value to your variable. I hope you guys understand what integer means. It stores decimal number, and it actually have the memory address, or it has memory address of, or it stores 4 bytes in memory. So I hope you understand what that is, and I hope you understand what box and what variable it is. A pix that actually stores, or that stores a specific data. Is a piece of memory that is used to store specific data. So that is what variable is. So I'm going to explain more about variable as we continue. So now instead, the first one here, we have what called brace initialization. So most of you guys should have, maybe if you are not if you haven't really actually start or begin with code, I know this will be surprising to you. So this is what we call brace. This particular one is what we call brace. So brace initialization, you can actually use brace initialization to actually give the value to your variable. But in the first one here, we have integer declared, and we have char, and chars has nothing in front except the semicolon I actually indicates here. So that's everything that is used here. So variable may contain trash in memories and warning. So if you declare something like this, it's probably will contains junks. I mean junks in memory, because once the compiler see, or the memory see that you didn't assign any value to this, it's going to drop any types, it's going to drop any chunks of memory in it without actually assigning it or giving it value. So it's going to store anyhow memories in this particular stuff. So it is very bad you declared your data types, or you declared your variable like this. It is very, very bad. So the right way you have to do it is by initializing it to 0. So you declare your variable, so you declare the data types, and you declare your variable, which is box, and the value of the box you either put 0 here. So you initialize it to 0. So this is what, so now this is what we call brace. Like I said, this particular one is what we call brace initialization. So in the next one, we have what we call its bike. So a bike, we declare the data types of integer, and we use variable of bike, and we store 6 in bike. So now we should understand that the value of our bike is 6, because before the bike does not exist, and we call the bike, and we give the value of 6 to the bike. No, now bike is now 6. So now everywhere we declare, or everywhere we see bike, we actually have the mindset like the bike is now 6. So now we have another initialization, and we have what we call it lorry, and we use brace initialization here. I mean. So in brace initialization, we have 10. So anywhere we call, anywhere we use our lorry, we should have in our mind that lorry is now 10. So lorry has the value of 10, and this does not have any value because we didn't give it any value here. We just declared the memory and just call the curly braces, and we didn't give it value, so it's gonna be empty, 0. It's gonna be just 0. But this is probably can be 0 and can be junks, can be anything, can be probably anything stored there. It's possibly stores anything there. And if we should go down here, sorry, okay, I think okay. So now if we should go down here, we said can express an initialization. Sorry. Okay, so now we actually declared another variable and data type here. So we said land transportation. Sorry. We have what we call land transport. I mean. So inside line transport here, this is what we call variable also. So we actually do initialize to variable here. We said bike plus lorry. So bike has the value of 6, and lorry has the value of 10. So whenever we do this, we add the value of bike plus the value of lorry. So it will be stored in our new declared variable, which is land transportation. So we are trying to get the numbers of the land transportation we do have. So in this format, we use brace initialization. So brace initialization give us the access to initialize or to give our value or our variable a mini, or give our variable a data. So that is what to actually do here. So we make up this and give the value of 6 and 10. So 6 plus 10, and it is stores in this place. So wherever we use land transport, we should have in mind that what is stores in this particular place is what we call is the addition of these two variables we have here. And if you go to the next one here, we have this kind of bad code. And how do you, or what did I understand by bad code there? So the bad code is that I declared uninitialized or unused variable. Like in our code here, we didn't have anything that is called does not exist or does exist. So we didn't have anything like this. We did not actually give integer int and we declared this. It is what we call bad error because we didn't, sorry, it's what we call bad code because we didn't declare or we didn't give this mini, we didn't initialize it to variable. Even just like this one, we didn't give it anything. We just call it int land transport and we did call it braces. That's brace initialization, and I add what we have here, and the unknowns, this stuff does not exist actually. So me adding anything here plus what is here is still meaningless. So it's error because this particular variable here does not exist. It does not exist at all. So this code we have here won't allow our programs to run because we have bad code here, and it won't allow our programs to run. And there is one of very good reason of using brace initialization. The advantages of using brace initialization is because if we declared our brace initialization and we give it the decimal fractional number, which is 4.5, and we initialize it to 4, so car, it's gonna return error because this value is a double value or float. You can use float or double value, but we are using it for integer. And I told you before, and I actually said, and I actually told you guys that integer actually stores decimal number, not floating point number or not fractional number, just decimal number. But here I am actually using a wrong one, or I'm actually using a wrong method. I'm using 4.5, which is not decimal. This is fractional. So if you should actually use this particular code, the compiler is going to return error because this one here is not fractional number. It's just decimal number, and this is just variable. Just trying to accept what we have here, but what we did here is error. It's typically error, so it's going to return error for us. And we should go to the next one here. So we have, sorry for taking too long. And so in this particular page here, we have what called functional initialization. So functional initialization will allow us to initialize our value in this format using open parentheses, and we close our parentheses. So in this particular one code here, we have integer and we have bike, which is our variable, and we have 6, the value of 6 stored in our bike, just the way we have it in our last or in our previous slide. So we have lorry here, and it has value of 10. So we have the two by using functional or by using parentheses. So by using functional, let's just say functional initialization or function initialization. So we store our data there and what we give it here. So that's how functional initialization work. Just the way brace works also. They also work in the same ways, but they has their benefits or their usefulness, or they has one benefit more than each other. So in the next line here, we have what we call just the same thing we have in the previous class, and we have integer and we declared car, and we give the value of 4.5. In our code, this code is going to work fine for us. it won't return error. But what the compiler is going to do is that it's going to clear this thing away for 1.5. It's going to clear 0.5 away, because the compiler will just use this mentality, and actually with functional it's going to use this mentality and said 0.5 is not integer's value, so it's going to remove it from the memory and give it the value of 4. And that is a very bad error, because if you use this kind of codes in your software and you declared integer char and you give the value of 4.5 on the norms, the reason why you give the value is because you need the value of 0.5 and it has meaning or it has purpose serving for the software, and you declare something like this, it's going to chop off this particular stuff away from it. But if you use this curly braces initialization, it's going to tell you that you have errors in your code, meaning that what you declared here is error, but in this particular place here it's going to ignore what we have here, ignore 0.5 here and allow 4 to go. So I hope you understand that. And the next initialization we have is what we call assignment initialization. So assignment initialization is very easy and it's very common and most used, but I won't prefer to use assignment initialization because it's not perfect enough. But still, this is one of the most used initialization in programming language. People use assignment initialization at any times, anywhere, every time. So assignment initialization is just using this equals to and giving it the value of 6. Once you declared integer and variable and give the value, you declare 6 in front of this value or data as we have here. It's going to see bike at 6, and the same thing here works as lorry too. It's going to give the value of 10 to lorry with the help of this assignment initialization or assigning initialization. So the same thing happens to this place too, and just like the previous lecture, it's going to chop off this one away also with assignment initialization, except if you use curly braces, or if you use brace initialization. That is when things is going to look good for you. So I hope you guys understand what this initialization means, and I hope you guys understand it, and I hope it's not that complicated for you to understand. So here we have just 3 types of initialization in our C++ language. So we have curly braces. I hope you guys understand what brace initialization means, and I hope you guys understand what functional initialization means and assignments. So I hope these things are clear to you. So in our next slide there, so we're going to check this in the memory though when we get to our code editor. So we're going to check the size of integer in memory. We said the size of integer is 4 bytes. It stores 4 bytes, or it takes 4 bytes in memories and stores the value of 4 bytes. So it doesn't go beyond 4 bytes. So now we're going to check the size of integer in memory, and we're going to check the size of lorry in memory also. Because we declared lorry here, and because lorry has the lorry is known as, or lorry is actually known for integer. So now lorry is now integer. So wherever we declared or wherever we use this size of lorry, is going to have the same value it has, because it is actually having or connecting to integer in memory. So they have this connection in memory. So when we check the size of this, it's going to have the same size in memory, So here we have the numbers ints in memories. So this is how int works in memories, and for this particular one here, it's 4 bytes. So this is 4 bytes in memory. This is 4 bytes also. So this is 4 bytes. So wherever we use our int, and sorry about that. So wherever we use our int in our programs or in our code, it just takes this whole data here, and whatever value you assign to it, or whatever variable you assign to it, you just pick it. If you assign 10 or 5 as the value, it consumes the value of 5. Maybe it takes 4 bits, which is 1 byte, or it takes 2 bytes, and it just manipulates the data in our memory. And I want you guys to understand this is integer or int in memory, and each one that represent each one we have on top of it, each one we have on each row here is called 4 bytes. They are all 4 bytes. I mean 4 bytes. They are all 4 bytes in memory. 4 bytes here, 4 bytes here, 4 bytes here. I mean the long part here, 4 bytes here. So store 4 bytes like this. That's how it works actually. And let's go to our next slide here. So now this is going to bring us more understand about the way we initialize our value. So here we have data name, we have variable name, and we have initialized value. So let me explain this to you guys more, so you can understand what I'm actually saying. This data name is the property of C++. I hope you understand what I'm saying. So this one we have here is the property of C++. Is the property of C++. So what are the property of C++? I explain the property of C++ can be in this format here. Sorry, can be these are the property. I'm coming. So these are the property of C++. We have integer, we have float, we have double, we have char, we have boolean or boolean actually. So we have auto, and we have void, we have string, and we have many more. There are a lot more actually. So in this part here, we have a breakdown of what data types is. So data name. So data name is the first thing that should be used here before we can declare anything, or before we can use anything in our code. We have to use the data name first. And like I said, before you can have access to C++ first, or C++ property, the things that are inside of C++, the things or the protection in C++, you have to have access. I mean, you have to declare the data name first and the types name first. After the types name, then you declare the variable name. The variable name is the a piece of memory that holds the data, or in this particular value. Okay, let's just say let me just use variable in this format. So let's say this is variable. This is variable. It's a box. Variable is a box that accepts or that points. Variable is a box that points to the value or to the property of C++. So when we declared our property, or when we use our property, which is the types name, and we declared the variable. So now it will be empty. When we first declared it, it's always empty. Let's say it's empty first. It's empty. Let's say it's empty. So this thing we have here is empty, and then so a variable can be in this format that actually is a kind of, let's say it's a kind of box that actually, or let's say it's kind of refrigerator. Let's say it is a refrigerator that you can store things inside of it. So that you can store things inside of it. Maybe you can store let's say soft drink. You can store these different kind of things inside of it. So it's just like a container. It's a container that gives access for you to store specific thing inside of it. So now let's say this refrigerator stores numbers, or let's say it stores decimal. Sorry, let me make this thing clear. Let me clean everything. So now let's say this is a refrigerator. And this refrigerator here we have here is our variable name. So we use the refrigerator to represent our variable name, and what can be stored in our refrigerator is meat, or let's say frozen food. Let's say frozen food. That's error. Hey, I'm very bad in drawing. Very bad. So frozen food. Good. So try and understand what I'm trying to draw. So this is frozen food. So this is my refrigerator, and what can be stored in the refrigerator is frozen food. And frozen food representing the type name. That is, my refrigerator is representing the variable name. So what can be stored in my refrigerator is frozen food. And we cannot store soft drink in our refrigerator, because the refrigerator is made the refrigerator is made for frozen food only. The refrigerator here is made for frozen food only. We can't not store soft drink in our refrigerator because it is for frozen food. Once we store this specific something here, something goes wrong. Maybe the soft drink might actually leak, and the drink can pour on the frozen meat. It can be turkey, or it can be chicken, it can be meat or beef, anything, mutton. So anything it is stored there. So if soft drink is being loose or leak, it can be pour, or it can leak on this particular stuff, and everything here is probably is going to get spoiled or get damaged, because we actually put the wrong item inside the refrigerator. So like I said, the type name is the frozen food that we can actually put there, and the variable name is the refrigerator himself. And this particular one here we are is what we call value, initialized value. So the value we can actually store is the meat. It can be meat, of course they are all meat. So let's say turkey, I'm not sure I'm correct with that turkey, but don't worry. So turkey, or I think I'm correct. So turkey, we have mutton, so we have a lot like that we can actually store. So these are the value, they are the initialized value that we can actually store in the refrigerator. So I hope you guys understand what this actually means. So those are the things we can actually store. We can store meat, or they are whole meat. We can store turkey, we can store mutton, we can store a lot more. But as long as they are frozen food, we can store. As long as they are frozen food, we can store them inside the refrigerator. And the refrigerator represents the variable, and the frozen food represents the data types, and the soft drink, and the meat represents the initialized value. So I hope you guys understand what I'm actually mean. So this is going to be the value of your. This is going to be the value that is going to be stored in your variable, and your variable is being known for what? It's being known for what? Integer. And integer what stores what? Or let's just bring it down to the knowledge of our code. Let's just bring to the knowledge of our code. Let me just clear this in a way. So now from the previous explanation, now I'm going to bring it from. So now it's going to be what? Decimal number. It stores what? Decimal numbers. Oh, that decimal is not correct. It stores decimal. Hey, decimal should be E. DCE. I'm coming. Sorry. D A C I M-A-L. So now this stores decimal in memory, or let it store decimal, and this one here is our variable. It is a kind of container, container. So it is a kind of container that allows us to store this particular decimal in the memory. It is a container that allows us to store this stuff in the memory. So now this is the initialized value. Initialized value can be is the specific number or the data we are talking about. So it can be in any format. It can be numbers. So it's definitely numbers. So it can be 1, 2, or 3. So this is our data types, which is integers, and this is the container, and this is the actual value. This is the actual value. This is our container, which is the variable names. So this is our data types, which actually takes only integer, From the previous lecture, from the previous explanation, I hope you guys understand that the way I open up refrigerators and stuff like that. So that's everything about how you initialize your variable, or what is variable himself, what is variable, and what is data types. So there are different types of data types, like I said, but in today's lecture we'll be talking about integer. So I hope you guys understand integer first, so we understand what we can actually initialize in integer, only decimal number, and it takes 4 bytes in memory. So I think that's the end of today's. So let's head to our Visual Studio. So let's do something there. Good. So in today's lecture, we're gonna be declining. Sorry, I don't need this. So in today's lecture, we'll be actually talking about integer. That will be lesson 7. See, lesson 7. Anyway, so sorry, that will be integer. So integer is going to have this specific value, and going to be stored here. Okay, now my my code editor is in this mode. Before I actually change the property of my computer, I use white mode. That's why it comes up white mode. That's why it comes up white mode before. Now, so now let's just work on integer. So let's clear this particular code away, and I don't think I need to zoom anything. Let me just zoom so you guys can see it properly, and I should be able to see it in that way. This is fine. Let's just use this way. So now we have, first thing we have here, we have our, and sorry I didn't talk about something. Oh, don't worry, we'll talk about it in this particular place here. talk about it here. So now let's just continue. We have what we call we have brace initialization. Or before brace initialization, let's just declare it. Let's use brace initialization direct, because that's the first thing we actually treated. Brace initialization. Oh my god, initialization. Okay, if I'm not correct, I'm sorry about that. So now we have brace initialization, and let's use brace initialization from here. So first thing we have to declare this. Let's declare something like this, and boss, and let's say this is going to be 0. Or let's just copy what is there, and so it can be so easy for us to, so it won't waste our time. Let's just have what we have here. You can actually do yours. You can do yours, but in this place I am going to use this specific code. So now it's gonna be easy for us, and because we have used a lot of time, we have exhaust time. Good. So let me just comment this code first. So now we have brace initialization. So this particular one here is junks, definitely junks. The trash. So probably trash has been stored in the memory of this car here, because we didn't give it any value, we didn't give it anything, and in the memory it is installed, or it's been initialized to junks, because we didn't specify values to it. And in the next one here we have box, and we just call a curly braces, and automatically it is initialized to 0. And also we have bike here, and bike has 6, and we have lorry that has 4, and here we have them together. So let's do something very easy here, and let's just try and do something. So go here. So now I have numbers of, let's say number of box. I give it no value, and this is going to be recognized as 0. And if we should, let's declare this false. Let's declare the one we have up here, and let's see what's going to be inside of it. Probably it can be 0, and it can be anything. The car can be in the form of anything. It can be junks, it can be anything, it can be minors, or anything data. It can be stored in the memory of 5, because we didn't give it anything. So the compiler is going to store junks in the memory of this particular value we have here, this variable we have here. We're going to give it junks in the memory. So it's probably can be 0, it probably can be anything. So let's try and do some things and ramp everything up together. So yeah, we're going to have numbers of land transport. So we have land So now, good. So in this place here we have numbers of land transportation, and the numbers of land transportation is the addition of the bike and lorry. So in our program, you know, this is going to be empty. Even if you had it here, even if you had box there, so it's going to have the same thing we have here because we didn't have any value here. So let's just use it in this way, and let's run the code and let's see what's going to be our results. Okay. All right, so in the next one, we're gonna understand how this particularly work. So we're gonna initialize or print it, send it to the console, and let's see how the compiler deals with things or data like this. So after we print this, let's check this first. Let's check how our compiler understand what we did here and how our value is being treated. Let's try and understand what is it first. And we are just giving the compiler the permission to go into our code and run our code one by one, or check our code one by one, I mean. Oh, come on, slow. What did I do wrong? Cowards. Okay, is already giving me the error self. It's already okay. I will declare the code. Oh my goodness, I will use the code. That's one of the errors that brought up here. You know, I actually initialize car here, and it has been given a memory. It has been given a memory in the compiler, or in C++. It has been given in memory car. You can't, meaning that you cannot reuse your variable. You can't reuse this variable. Once you have actually declared car, you cannot declare another car again. It's not possible to declare another car. That is why giving us error. So let me just add s to it, or we can change to something else. There are a lot of transports, a lot of land transports, so we can actually use we have logical. Let's see, I don't really know much about that, so let's just say machine. So now let's just say machine, and we know that these things, they are not of the same type anymore, so our code is going to run. So in your programs, you can't use names like you use car, you declare car before, and you declare it again. Your code will not allow that, because it has actually give this one space in the memory. So it has give cars space in the memory, so whenever you use it, it's going to ignore it, because you are using two of it, so it won't allow such to happen. It's just like error. Okay, still giving us error again, because we have code conversion. We have still giving this error, but I don't want this error particularly. I don't want to deal with this for now. I will explain that later. My god, I just want something called to print. It's stressing me. I just want this one to print false before I go to the next one, so I can explain that. Okay. Okay, our binary code has been successfully run, and let's try and check what we have inside of that. So now you're gonna see everything being easily printed on the screen, and there's gonna be no stress-free. It's gonna be what we are going to be experiencing. Oh my goodness, please be fast. So now we have CodeLab, and exactly what I'm saying. Like I said, see, car, did I give it any value? I didn't give it any value in the memory. I didn't give it anything. So automatically the compiler gives it the value of 1. You see, car is having 1 here, which we printed here. Car is having the value of 1. I didn't give it the value of 1. So it is very bad for you to declare code like this and use it. No, you have to initialize it immediately you are declaring the variable. So it's very bad. So if you have the next one here, we have 0, which we did properly. Even if you don't have anything to give it, just initialize, or I mean just do it in this method that you call up the initialize or brace initialization, or anyone you want to use, maybe brace, functional, or assignment. Just make sure you do it something like this, and didn't give it any value, so it's going to give it automatically. We're going to assign the value of 0 to it. So bike we have 6, and lorry we have 10. So here we have what, 16. So we had both box, bike, and lorry together, and it gave us what, 16. So even if you have add this particular stuff car to it before, so it's gonna be 17, and which is error, very bad error. So stuff like this, they can call bugs like that, and you get confused. How comes my values having, or how come land transportation is having let's say we have 16, so it's having 17. So now this one is going to be added together with this one, and you'll be confused. How is it having 17? Because you actually give it 16, 6 and 10, and you add them together and give it 16. So what you expected as a programmer is what we call 16, but because you have made error, you didn't give this value, and automatically your numbers is now 17. So there's going to be issue. Even if you rerun the code again, it can give it another value again. I'm not sure if you expect 1. Let's run it again. It's possible you expect 1, or it give it 0, or anything again. Let's try and run it again and see what happens. So now good. So let's try and check our code again, and let's look what is inside our code now. So let's just run this. Fine. Okay, good. I love this. So I told you guys, this is gonna have trash in memory. Now you see what is here. We have minus 1670. What's this? I didn't give it those things, and we have 0 here. Norms, sorry, I have my antivirus which is actually giving me, sorry, I should actually have stopped this. Sorry for that. I should actually have stopped that. So now I have junk stores here, so I have the value of 1670. I don't know what this is from. I don't know where it's from. So box, I know it's supposed to be 0, and here it's supposed to be 6 and 10. And I had everything I have here together, and it gave me what, this is not my expectation. This is not my expectation. So this is an error. So don't this is a warning to you. Don't call or initialize your value in this way. Make sure you do it in this format here, that you give it the initialize method, maybe curly brace, or maybe brace, or curly brace. You can only curly brace or brace, or maybe functional or unsigned. So whenever you do it in this method, you won't have this problem here. So avoid being initializing your value like this. So it's gonna give it junks in the memory. Even if you run it again, we can even expect another thing again. Let's run it again, and let's just play with these things for a while. You can even play with this for a while and do it on your method. So let's try and do it again, and let's see what's going to be inside. Again, it's going to store another value there. So it is very bad for you to declare stuff like this. So make sure you initialize it to a value. It's very bad. So let's wait again, like we have been waiting. So successful, very fine. So now let's try and we opened it again. So dots, so good. Again, you see what again? You see what we have again? We have 98554. So that is how the compiler will give randomly, giving it chunks, something that is meaningless, that we don't even assign it. So always make sure you give your variable an initialization, or even if it is going to be empty, just make sure you initialize it. It is very, very important you do that. So else this error keep happening, and this is not my expectation. My expectation is what, 16, and yet I'm having 999,000 or something like that. Or let me check it, how many zeros is there? Okay, let's say million, 998 millions or stuff like that. I'm expecting only 16. Oh, you see, that's how error do occur. So don't ever declare your stuff like this. Just a warning for you guys, and I hope you I hope you notify that. Just keep that in record. So now we will talk about this one, actually, bad codes. So we know this is just bad code. This one here is bad code because it does not exist. If we should run our code here, the compiler will not run it for us, because this particularly is not initialized, does not have any meaning, or in our memory does not even exist at all. So this stuff does not exist. It's just like meaningless, just used, something that occur like alien. So let's say this is our alien, this is an alien to our code. It does not, it's nowhere, it's from nowhere, it just come up from the code. So yeah, this is here. So saying from line 16 here we have problems here. So does not exist, was not declared. So said was not declared in this scope. So meaning that I did not use this particular data here. So it affects our code because I didn't really use it. I did not initialize variable to it. I didn't call it up from anywhere. So this is a very bad method of using this stuff, or not even bad method. Just be carefully attentive, or be aware of what you, when you declare your variable or when you don't declare a variable. So this is a very bad code. And the last one I want to explain from this part here is this one here. So if we print this thing here, let's say we print it, and we print our code. So let's say machine, and we run our code again, and let's check what it's going to give us. So now we have very, very bad error. Like we said, double to int. Like I said, this is the value of double, and this is the value of double, and we are giving it the sorry, this is the value of double, and we are initializing int here. So it's throw error. It does not go forward, because this is a very bad code, and you should not do something like this. And make sure you use your brace initialization, and you will see the benefit or the excess of using this brace initialization. Once we use that, let's just comment this and comment this also. So now let's go forward and let's declare it. Let's use functional initialization. Let's use functional initialization actually. So let's just comment all this one, so it won't look comment is too much. Comment. So now let's just do something very easy. Commenting everything here. So if you want to do what I'm actually doing, just unlight your code and press Ctrl and your slash, the right slash, just press Ctrl and slash. It will automatically comment everything. Just unlight it. Once you unlight it, Ctrl and slash, it will work actually. So now let's just use functional. So functional initialization could be, okay, let's say car, and no, I won't use this one again. We have understand how that should, let's say int box. So box is nums 0, but I won't really go far like that. Let me just explain something very easy. So let's say box int lorry. So lorry have, and let's say bike, and the bike has 11, and we can actually do the same thing we have here. And lorry plus bike, and we can actually have the land transportation, so we won't do much here actually, since we have actually explained it from the previous section here from the curly braces. So what I will just try and bring up here is that I will declare, and this particular code, I'm coming. I will use this particular code here and see how the difference is. So we check and we try and navigate or try and check the difference between you, or the reason or purpose of using your brace initialization and your functional initialization. Same thing, let's try and check it, but let's wait for this to actually finish. Good. So now let's try and, okay, is it good? Something is wrong. What's going on? Box, I actually comment everything. Box, what happened? Okay, come here. Okay, because I declared, okay, I didn't give it value, so I should have given the value of 0, but does not support this. It doesn't support you putting the value of 0 to you. You cannot just use functional initialization without giving it any value. So let's just give the value of 0. So make sure you give the value of 0 when you are using your functional. Make sure you indicate the value of 0, or it throws warning. So you see how those errors and warnings to occur from our previous topic here. No, it's built successfully for us now. No error. So make sure you just try and check and try and understand how the code or how the compiler deals with your code. So you try and understand that now, because we didn't give it value, it's throwing error because we didn't give it value. But when we use curly braces, nothing happens. It went fine, everything was fine. But when we use functional, something was wrong. Just try and notice all those points. Try and notice those things there. So try as much as possible to notice all those points and how those things work actually. So now we have 100 and what 15. So this is just normal thing that you should expect. So I don't think this should be so obvious to you guys. So now let's declare another one again. Let's say cars having, okay, parentheses, let's say 10.11, and let's print 10. So now we're going to say the value of car, and we declared it, and what use build and build with GCC. So let's hold on and check what's going on. Okay, good. So now we will try and check. You see, it's built successfully, nothing wrong. But when we use curly brace or brace, sorry, I mean when we use curly brace and it throws error. When we use something like this, it throws error. But yes, it gives us or it complies successfully and nothing is wrong. Let's try and check. So it's, oh my god, something happened. Okay, I didn't even call it. Oh my god, what is wrong with me? Oh, I didn't notice that. So please, I am so sorry. I am very sorry. I am so sorry. I don't notice that, seriously. I have to rerun the code again. So the cars, let's check what is going to be in the car. Okay, fine. So now let's try and check what is inside this place, and yeah, let's try and check its lab. Find 10. You guys see what I'm saying? This is 10 and y 1.11 is gone. So it chop off this part here and give it the value of 10. So you can't not use, or you should not use, or it's not advantage, sorry, it is not encouraging, or it's not encouraging for me to you guys to use functional initialization, because it's very bad. You don't usually use functional initialization for something like this. You don't use something like this. So it's mostly, or probably, let's say it's mostly considered for curly brace. Curly brace is very good to initialize the value. Even this one automatically give us 0, but when we use function, it throw error because we did not give it value. So now let's try and use the last one, which is the assignment. So assignment, let's try and come up with something new. So something new, let's say dog equals to 10 and cat equals to 16, and we have domestic So let's say we have domestic animal and we had them together. So we have dog, flows, and cats. And where we did this something like this, we can just bring them out. So domesticated animals, the numbers of domesticated animals is this. So let's say domesticated so now, and let's try and run the code. And no, not all. So let me try and use this last one. And let's say cats, fish. So now let's give the value of, let's do the same thing we did in our functional 15.0, and let's do the same thing here also. So now let's try and run this code again. Okay, so now view, so terminal, and let's try and check what we find in our code. Okay, good. We have domesticated animal, which is 26. So 10 plus 16, 26, which we add here and stores inside of this, which we add and store inside of this domesticated animal. We have honey, so we have fish, which has 15.11, and yeah, 15.11 is gone. Why? So now it is bad to initialize your value to using your assignment or using your functional. They are both bad, or let's say it's not encouraging for you or for me to you guys to do something like this. So try and notify or try and understand why those things is not actually going fine. And in the last method, or in the last method there, let's try and understand the size of this in the memory. So I'm going to take the size of integer in the memory. So let's take the size in the memory. I'm going to print the size of ints. So I'm going to write size of ints, then let's say bytes, and we're gonna check the size of any of the variable we have here. We can use any of the variable we have there. It will give us the same value, even if I'll try more than one for you. So let's say I use size of dog. So let's say size of dog. So size of dog in memory, and I'm gonna use another one again. Let's say size of domesticated animal. I'm gonna use more than again. So for you guys to notice that they are all 4 bytes. Once you initialize the value, so it's all 4 bytes. Even if I use fish again, I'm gonna use fish. So I'm gonna be using everything so you guys can understand that they are all 4 bytes in memory. Once you're using, they are 4 bytes in memory. So yeah, I'm use fish. Yeah, I have domesticated, undomesticated animal. So now I'm going to be dividing the string. I'm going to be dividing the string in our code. So you try and notify or try and get the value. So let's just put just this there, and let's try and run the code, and let's see what's going to be happening here. Let's see what's going to be happening here. So now let's run this particular code and let's check it out. And so that's how, or that's more about integer. That's just about integer. It stores decimal in memory and takes 4 bytes. So it stores decimal and takes 4 bytes in memory. So that's things about integer you should understand. That's things about integer you should understand, please. So now let's try and check the size of these things in memory. So good. I enjoy this. So now we have integer in memory is what? 4 bytes, which is here. We have dog, 4 bytes also. We have domesticated animal, 4 bytes also. We have fish, 4 bytes also. So they are known for 4 bytes. So because I gave the value of or I actually make it integer data types and give it the value of, or I gave it the variable. So the variable also is known as the size, because you have actually initialized the value to it. So because you actually call it up from the data type. So that's things about variable, and that's about the size in memory. And let me try and do something again. This is, or let's say this is just a bonus. If you feel like you can just continue. This is just a bonus or tips class. So there's what we call conversion, name conversion. And I think it's important. You can just carefully listen to it. So name conversion is a kind of way that you, or is a method or process you, sorry. So it's a process or method you write your, or you codes, or you bring your first sentence or your sentence, you make your sentence in your code. Ways you make up your sentence in your code. Example, you can start your sentence with something like this and initialize the value to it. You can't start your, okay, I declare integer and I did something like this and I give it a value of 10. Should be error. Should be error. So it's giving me error here. Error because this stuff here does not make sense. So there's a way you declare your variable from the beginning of the sentence or from the beginning of the text. There's a way you do it. You don't declare something like this, it's error, or you don't declare something like this, it's error either. Oh, this cannot be error actually. This cannot be error. So let's use something else. So let's say this is error. Does not have meaning. This is error, should be error. The last sign. Sorry. I think there are a lot of error like that. Yeah, this is error. I think those ones they have there's meaning, there are data types in memory, sure. But there's a way you declare your value, your variable in the in your programs. So we have what we call name conversion. So we have different name conversion. We have Pascal case. We have Carmen case. We have snake case. We have Algerian notation. Algerian. Oh my god, can I spell this Algerian? Anyways, Algerian is wasting my time. I don't think that's correct, but Algerian notation. So now Pascal case is a method or way you declare or use your variable. Example, when I declared my integer, now I do something like fish and I give it value, or I do something like bottle and I give it value. But what if I wanted to add two variable names to it? So they say bottle and bottle drink. So it looks very complicated for you to understand. So for you to know that these things are two words here. So because they are together and it's not making sense. So one way you can do this is by using name conversion. So name conversion is just the way you identify, or the way you understand, or the way you make your codes understandable or to maybe readable. So if you do something like this, it is not readable for me. So, or it is not readable for some other people, because and it's not readable for me to if it's something that is difficult or something else, but to drink. So now if you want to do something like this here, using name conversion to make it more readable, let's start from the one, let's say Pascal case. Pascal case can be in this one. So let's say now we said bottle, start from capital letter B, and bottle, and drink gonna be start from capital letter also. And this is what we call, so now this is what we call Pascal case. So this is how Pascal case work. So the first text of the first letter is going to be capital letter, and if you're adding the two variable together, just a bottle drink, so it's going to be capital letter also. So now if we have more than example, I have domesticated animal here. If I want to complete it, I'll just animal here. But now this is another case entirely, but I'm going to tell you what case is this, but not now. And this is a Pascal case. You can actually use this one to join two names together. So you don't still have another one again. So let's say camel case. So let me comment this out, and camel case works in this method that first letter is small and the other letters are capital letter. Even if you want to add more, maybe drink and then soft, it's gonna be what? Capital letter. So the first one must be small letter, and the next letter must be capital letter, and the next one must be capital letter also. So that is how Pascal and camel case work. That is how camel case work. So you can actually use it this way, that you make the first letter small letter and make the next letter that follows, if it is more than one variable names, so make it capital letter, and the next one to make it capital letter. So that is camel case. So this is what we call Pascal case. So Pascal case can actually have another, like look at this sub can actually be 0, and this is how Pascal case work. So every first letters in the word or in the text is capital letter, but camel case make the first letter small letter and the others capital letter. So now let's comment this out and let's try and understand how snake case work. So snake case is the one I have been using. I have been using snake case. So integer, and let's say snake case should be bottle. So bottle drink and soft and 3. So this is snake case. So snake case actually works in this method, that after every text or after every letter it comes with underscore, and you type, even if it is more than one variable, so you use underscore again, or if it is more than one text you use underscore, not variable actually, use text. So if it is more than one text, use underscore. So this is the way snake case works. This is the way snake case is being used. So now we have another one again. So we have Algerian case. Algerian case is a Algerian case is a very old, like it is one of the early programmers' method of declaring, of using their variables. It's a very old method of using that variable. So let's say Algerian case actually start with the first letter. If I'm typing drink, first letter start with, or it's usually start with small letter and the others start with capital letter. Stuff like this. And drink like this. Sorry. So and drink like this. And soft like this. But the first letter starts with small letter. So that's Algerian case. That's Algerian case. But people don't use, or the programmers don't use Algerian case again, because early programmers do use Algerian case. Algerian, I can't still spell Algerian again though. Algerian. Algerian. It should be I-A-R. Oh god. Anyway, anyhow. Okay, this is it. I get it. I got it. Should be Algerian. It should be this. Yep. Yeah. This is the correct spelling. I can picture the correct spelling, but I don't really can't grab it. So this is Algerian case. So this is Algerian case. The first letter starts with small letter, and the next one starts with capital letter, and the next one starts with capital letter, and this next one starts with capital letter. So if you want to use your variables like the one I've been using since morning, so I have land transportation here. I'm using snake case. It's probably, if I don't feel like using snake case, I can actually use Pascal case. So Pascal, Pascal case should be capital letter first one, and next one should be capital letter. So it should be like this. and I can just say lorry plus bike. So and it works. So that's it. That's for Pascal key. And I can also use for camel keys. I say camel should start from small letter and should have T, capital letter T and what? And lorry should add bike. And it also work. So this is just camel case, and try and notice all these methods very well. So you can actually decide on which one you want to go for. In out of the case we have here, you can actually decide the one you want to go for. Is it Pascal case, camel case, snake case, or Algerian case? So anyone. But really, programmers don't use Algerian case anymore. Only these cases that I actually knows, and they exist actually, still existing, still living. Snake, camel, and Pascal. So you can actually decide to use any one of them, but don't use any kinds of symbols to start stuff like this. It's very bad. Like I told you, this is the method you declared your stuff, and don't use signs or symbols to start your declaration of your variable. It's very wrong. Don't use stuff like that. Okay, please, I'm begging you, don't use stuff like that. So that was about case. So, and I want you to understand that C++ is a very case sensitive. As an example, if you declared case is a data type. So let's say you declared union. I think union is a data type also. So union is a data type. So let's say you declared clothes, and I give you the value of 10. That does not mean that clothes and clothes, they are the same thing. No, they are not the same thing, because you use capital letter C here and you use small letter C here, so they are definitely not the same thing, because C++ is a case sensitive. It notify every letters in your code. So now this case clothes and clothes, they are not the same. Even if I give the value now and I give it 20, it won't give me error, because these two things, they are different. This clothes and this clothes I have here, they are different, because this clothes start from capital letter C and small letter C, and this clothes start from capital letter C. Does not mean that these two clothes, they are the same thing. They are definitely different. So try and notify that these two things are different, because C++ is a case sensitive. It does not allow, or it does not help you sort this out. So it makes you notify that every code, every keys, or every text in your code makes sense, or has meaning, or contribution to your data. So make sure you notify these data I have here, the first one I have here and this one, they are not the same thing, because capital letter, small letter, and capital letter, they are capital letter starting with small letter and starting with capital letter here, make it different. So just follow this method I bring up here, case and name conversion, Pascal, camel, snake, Algerian, anyone you prefer, you can use it. So thank you very much, and I have spent a lot in this play on this lecture, and I hope you guys enjoy, and it's not too much. I'm very sorry. Bye.